good to see you again. And Ian is going to be telling us about monolithic micro LED arrays using organic thin film transistors.
So, thanks everybody. Welcome from dark and dingy London. It's a very cold, damp, dark night tonight. So I'm Ian Jenks. I'm from SmartKem. I'm going to talk today very briefly about some of the things that SmartKem does, and then I'm going to introduce you to a new and exciting development that we're announcing with monolithic micro LED displays. So I'll go as fast as I can. So we make inks. We make a stack of inks that allow us to a stack of organic inks that are based on organic semiconductors, and that allows us to make a range of transistors. Sometimes we sell our materials as single layers. Sometimes we mix them up and pattern them and produce transistors. And sometimes we make big arrays of those transistors and make displays. I won't go into the how we actually make up our inks, but suffice it to say, we make a full stack of materials that can be placed on a substrate. We make a base layer, organic semiconductors, gate insulator, sputter-resistant layers, and passivation layers. What's unique about what we do is we do this at the solution process, but we do it at 80 degrees centigrade. And that means that we can do it on low-cost glass and plastic, and it's a photo curing process, which means that we can pattern them using direct laser writing. And they've been designed, even though they're organic materials, to be able to be processed on amorphous silicon lines. But of course, we don't need the high energy consumption machines, the PECVD machines. And you can look at the know-how at a different time. So how do we actually take our things to the market? Well, our strategy is very simple. We enable customers to make the impossible, whether that is because they can't afford to build new infrastructure and they're looking for a low cost, whether that is because they want to do something on a different type of substrate, or as I'll show you in a minute, whether it's simply to do something that they cannot do any other way. I apologize for the ambulance. And our strategy is we show them what our materials can do, in particular the low temperature processing, but also our ability to maintain mobility as we go to very short channel lengths. And I'll show you a little bit about that in just a moment. We've developed a set of EDA tools that is an add-on module to the Cadence's EDA tool system, and we help them design products using our module with on the Cadence platform. And then we have a foundry service that allows us to make products prototyping at our foundry in the north of England, and to transfer that to their own process lines. We've just heard a lot about micro LEDs, and very elegantly put in much more detail than I could ever give. The reasons for going to LEDs are absolutely overwhelming. Much more efficient light source, self-emissive. They can be hugely bright and well above the need to well above the brightnesses that you need in order to be able to see them in daylight. They are use a lot less power. They last a long time, and you can read them in daylight. So there's and within the boundaries and the puts and the takes between OLEDs and micro LEDs, and micro LEDs with color conversion with quantum dots. What I find really exciting about the market today is that it's open for change, and it hasn't really been open for change. If you think about the number of different technologies that have come to the market in the last 30 or 40 years, it's very few. And now we have a very exciting time where lots of people are trying new things. So